In this presentation, I'll be discussing the gas laws and explaining them. This is brought to you by Mariam. Okay, so I'll start by Boyle's law, but first we have to know some properties of a gas. So gases have an indefinite shape and an indefinite volume, and their particles are widespread and they move rapidly in all directions. So Robert Boyle's law states that at constant temperature or at uniform temperature, the pressure and volume of a gas are inversely proportional. Now, the term inversely proportional means that as one of the pressure or the volume increases, the other will decrease, and if one decreases, then the other increase. The law describes the expansion or compression of a gas at specific temperature, uniform, non-changing temperature. The equation or the formula is P1V1 equals P2V2. Now, there are two figures here, and the temperature will be constant. We're not going to add or remove heat from any of the figures, but we're just going to pull up the handle. This means we're increasing the volume, so there will be less pressure because there will be less collisions between the particles. And if we push it down, we're decreasing the volume, so there will be more collisions between the particles, which creates more pressure. But as we said, the amount of gas is not changing, and also the temperature. So if the volume in figure 1 is almost double the volume in figure 2, the pressure in figure 1 is half the pressure of figure 2. This keeps our equation constant, and as you can see, as I increase the volume, I'm decreasing the pressure, and as I decrease the pressure, I'm increasing the volume. So they are inversely proportional. When a gas is under enormous pressure, it's compressed, which means its volume decreases. The temperature and amount of gas are constant. Now, Charles' law, which is the second gas law, Charles' law explains that when the pressure on a sample of a gas is held constant, the Kelvin temperature and the volume will be in direct proportion. Here, what's constant is the pressure, and temperature and volume are changing. So, directly proportional means one of them increase, the other will increase, and so if one decreases, the other will also decrease. The equation is V1 over T1 is equal V2 over T2. The law explains that when a gas is heated, it expands. If and only if it has uniform pressure. So we have to keep the pressure constant. Now, when a gas is heated, it gains energy and moves rapidly, which increases its collisions and increases its volume. So here the pressure is going to be constant, assuming that there is no change in the pressure. Figure 1 is just like less heat than figure 2. So as you're giving it heat and energy, it's going to expand, increasing the volume. So more temperature is more volume. This keeps the equation balanced. Now, Lasac's law. This law states that when the volume is kept constant, the temperature and the pressure are directly proportional. So here what's constant is the volume, and the equation is going to be P1 over T1 equals P2 over T2. Further explanation. Now here, the temperature is not constant, as you can see. We're heating figure 2, but now heating figure 1. So as a gas is heated, it gains more energy and moves more rapidly, causing more collisions, so more pressure. If T1 is half T2, or the temperature at the beginning is half the temperature at the second figure, then also the pressure is going to be half in the first. So they are directly proportional. As one of them increases, the other will increase too. And if one decreases, the other will also decrease. Now there is a combined gas law. The combined gas law is a combination of Boyle's, Charles, and Lasac's law. This law states that the ratio of the product of the pressure and volume and the absolute temperature of a gas is equal. So basically, P1V1 over T1 is equal to P2V2 over T2. So all of them are changing, nothing is stable besides the amount of gas. So if we have two figures and we increase the temperature in one of them, we're also going to increase its volume but decrease its pressure. So giving more heat to figure 2, which means this will expand, the gas is going to expand, so more volume, less collisions, so less pressure. This is where the formula comes from. So this is basically the whole, all the formulas in one slide. And I'm going to insert a link in the description if you want to solve some questions to make sure that you get the hang of it. Thank you for listening.